On March 11, 2011, the biggest earthquake in all of Japan's recorded history was a magnitude 9.0 that was centered off the coast of Miyagi Prefecture in northern Japan. The earthquake triggered a devastating tsunami that affected most of the northern areas of Japan. Uncountable number of businesses were greatly damaged, and the Ofinato factory of northern Japan's biggest cement manufacturer, Taiheiyo Cement Corporation, was no exception. The height of the tsunami that struck Ofinato was a staggering 23.6 meters. All of the debris was scattered everywhere because of the chaos and after effect of the quake. The task of cleaning all the debris was overwhelming for everybody. Additionally, many places that were struck by the tsunami were located by the ports, resulting in a large amount of waste from seafood processing industry. The damage to the refrigeration equipment caused serious odor problems, which led to an outbreak of swarms of flies throughout the coastal region. Our connections to surrounding prefectures and cities were already established long time before the earthquake, largely due to their issues of illegal dumping and our waste recycling and fuel production for cement manufacturers. We were in disaster area 4 days after the earthquake and started assessing all the damages that had occurred. Anything we can do to contribute, no matter how small the task. Rimatech's challenges for treating the waste from the disaster. The Great East Japan earthquake and tsunami produced 760,000 tons of debris in Ofinato City, 1,480,000 tons in Rikuzen Takata City, and a total of 5,250,000 tons in Iwate Prefecture altogether. 6 months after the quake, the incineration treatment capacity of all existing facilities in Iwate was at 200 tons a day. By our calculation, it would take up to 72 years if all the debris were being incinerated. Unfortunately, incineration treatment creates a residual product of ashes that weigh half of the original material's net weight. There was a need to minimize the amount of material being incinerated as well as the landfill treatment. In Iwate, there was only 100,000 cubic meters of reserve capacity for the landfills for all the coastal and inland disaster areas. There was simply no room to deal with the debris using only incineration or by burying it in landfills. Waste treatment was one of the most difficult tasks that needed to be dealt with. That's when we, Rimatech Corporation, decided to take on these challenges with our project planning skills, operation engineering, and accumulated technology. There were two main key points in solving these problems. First, maximizing waste recycling by minimizing incineration and landfill usage through different levels sorting waste materials from the disaster. Second, utilization of cement manufacturing factories with a treatment capacity of 1,000 tons a day as a main operation facility for the waste treatment and recycling. The recovery of Ofinato is faster than any other cities in the disaster areas. Despite a 2-month delay, by staying focused on these 2 points, our Rikuzen Takata operation is proceeding twice as fast compared to other places. Let's see what kind of cleverness made it all possible. It's been generally believed that an efficient recycling of resources requires an advanced sorting system at the early stage of waste processing. Processing the debris from a disaster follows the same steps. A sorting procedure gives more recycling value and reduces many leftover materials for incineration and landfill burial. During the panic after the quake, with all the local governments being unable to operate, it was necessary for us to come up with ideas that met the needs of all the work sites. Therefore, we began estimating the damages and developing a treatment recovery strategy and implementation plan. We suggested a 3-step recycling plan. First, we would sort out hazardous material, electric appliances, poles, concrete, and bricks from the demolition phase. Second, we would take all the sorted material to a temporary storage area and remove anything that was not suitable for the crushing phase, such as metals and easy-to-recycle materials. Finally, the waste would be taken to a secondary storage where all the waste gets crushed and adjusted into recyclable sizes needed to meet the cement manufacturing standards, and crushing and quality management lines are constantly on. By keeping a close relationship with the cement companies, we were able to maximize the utilization of hazardous waste materials for supplemental cement manufacturing fuel while keeping up with our quality standards. We put our ideas and expertise of efficiency to work. For example, when we were selecting temporary storage locations, we conducted research on the conditions of the land, the square meters needed, and a suitable entry and exit point. We also analyzed the delivery of the debris from the demolition sites and temporary storage area. We focused on efficiency and safety measures such as the prevention of traffic on bridges and avoiding areas. Timely assessment and planning created the basic structure of waste treatment from the biggest earthquake and tsunami disaster in the history of Japan. It is not an easy task to bring to fruition a plan that has never been done before. So we placed our most highly skilled and professional team to run the equipment and manage the worksite. They focused on finding ways to improve the operation and delegating all worksite assignments. They were also responsible for educating the local staff on any changes to the workflow. They diligently worked around the clock trying to establish their operation training for sorting duties in May, only 2 months after the earthquake, the operation of the crusher in July, and the desalination operation in November of 2011. We needed to overcome some obstacles in order to convert the debris from the disaster into some supplemental cement manufacturing fuel. Due to a high salt and chlorine content of the debris, they could not be recycled without desalination. We repeatedly conducted the experiments at our laboratory and had the demonstration experiments at work sites. We managed to build a plant that removes the salt and chlorine content from all the waste materials. And this facility has been in operation for 24/7 ever since. Although we sometimes encounter some difficulties such as hazardous and hard-to-recycle materials, we, Rematech Corporation, have the best research and development team of engineers and researchers making it all possible to achieve. Project planning skills, operation engineering, and accumulated technology. We have been utilizing all of these elements and have managed to deal with enormous amounts of waste. However, we could not have done it all by ourselves. Working with local companies as equal partners and not subcontractors allowed us to reach all our goals and overcome any tough challenges we encountered. We believe that when we implement any project, it is so important to learn about the people we work with, their cultures and backgrounds, and that gives us a chance to work towards the same goal together. Interacting with local people is what we enjoy doing the most, and we are honored to have such opportunities. Our 30-year relationship with the cement industry was the foundation from which we were able to build the waste treatment project. we are proudly keeping the standards of high-quality cement and working towards creating new energy conservation projects.
じっくり時間をかけて数字を操ってですね、計画通りに完璧なものを作る術はあるんだけど、スピードと展開力がないと、集中力がこれはだからお互いない者同士がうまくその歯車が噛み合うんじゃないですかね。そこは逆に言うとおそらく我々だけではできなかった仕事だと思うんですよ、今回の仕事はね。幸いリマテックさんは大船渡を足場にしておられたから、そういう足元を持ってたということもありますけど、いずれにしてもそのプラントにしろ人を集める術にしろ、それから特に行政や地元に説得し、理解を得て、方向性をきちっとあれするという、これのなんていうか、さっき言ったようなスピードと集中力と展開力、これでしょうね、これが素晴らしいと思いますよ。
From designing and planning to method development and treatment implementation, we are committed every step of the way. Anything can be achievable with Rimatech Corporation.